Today what I wanted to cover was the quadratic formula. So this is a little bullet list of the things that we're going to be covering today, some of the questions that are going to be answered. So the first thing is the introduction to the quadratic formula. So what is the quadratic formula? The quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c all divided by 2 times a. So this is known as the quadratic formula. Now the quadratic formula is useful to find solutions of quadratic equations. So first of all, what are quadratic equations? So quadratic equations, if you will remember, are simply equations like y is equal to x squared that have a degree of 2. And remember, degree, we're referring to the highest exponent. So something like this, y is equal to x to the third power, is not a quadratic equation. However, something like y is equal to x squared plus 2x minus 1 is a quadratic equation because of the degree. And just a quick reminder that this does not have to be in order, right? This is the standard form of a quadratic equation, but if you have it out of order, the degree is still 2. It's always just the highest exponent. Okay? Now, like I said, the quadratic equation, or the quadratic formula, like I said, the quadratic formula is useful for finding solutions. So what are solutions of quadratic functions or quadratic equations? Solutions are the x values that would make a quadratic equation equal to 0. Alright? So there's actually different names for solutions. We have covered this in the past, but you could call them roots. You could call them zeros. And when you see them on the graph, they're going to show up as x-intercepts. So solutions, roots, zeros, x-intercepts, we're going to use these terms interchangeably. So just make sure that whenever we talk about one of these, you know that we're just referring to the value for x that would make my quadratic equation equal to 0. Now, how is this going to help us find what my solutions are going to be? Well, notice how this has b, a, and c as variables inside the quadratic formula. Those variables are actually going to be taken from the equation given to you. So remember, this is going to be a, this will be b, and this will be c. Because remember that the standard form of a quadratic equation is y is equal to ax squared plus bx plus c. So when we're talking about a here, c here, and b there, we're literally referring to the value of a from my quadratic equation is going to go there. The value of b is going to go there and also there. And the value of c will simply go there. So you see, we've been working towards using the quadratic formula this whole time. You guys just didn't know it yet. The most important thing is going to be to figure out what your A, your B, and your C are. So far we've covered introduction to the quadratic formula, and we've also covered what are solutions, right? And remember, solutions, once again, when you see them on a graph, are going to be the points in which you intercept your x-axis. So the x-intercept points. So we're talking about this point right here and this point right here. Now, I want to tell you guys something, that by default, every quadratic formula is going to have two solutions. If I'm saying that by default every quadratic equation is going to have two solutions, then why do I have this third bullet right here, which is how to find how many solutions? Well, let's think about two different graphs. Actually, let's think about three different graphs. Here we have three different parabolas, and each of these parabolas, it seems, would have a different number of solutions, and they do in fact have a different number of x-intercepts. So this first one has one x-intercept at 0. This second one has a negative x-intercept and a positive x-intercept. And this last one actually doesn't cross the x-axis at any point. So x-intercepts is none. So it has no x-intercepts. Why is it then that I told you that each parabola has two solutions? Well, the reason for that is because this one has a repeated solution. This one does have the two real solutions. And this one actually has two imaginary solutions. So we're going to be talking a little bit about what that word means, imaginary, because it doesn't really mean what you think it means. So how would we find out whether we're going to have one solution that's repeated, two real solutions, or two imaginary solutions? We're going to be using a part of the quadratic formula known as the discriminant. And the discriminant is this part right here. Technically, just what's underneath the square root sign. So let's once again write down our quadratic formula. And this time I'm going to write in a different color what the discriminant is. So negative b plus or minus the square root of, and this is where the discriminant is, b squared minus 4ac all divided by 2 times a. This right here is going to be sort of like a formula inside of the formula. The discriminant is going to help us determine which one of these situations we have. So for this first one, we're going to have one solution that's repeated twice if the discriminant is equal to 0. Now, if the discriminant is a positive number, then we're going to have two real solutions. So this one is d is equal to a positive number. And for this one, we're going to have no real solutions and two imaginary solutions if the discriminant is equal to a negative number. Okay, so we have three different possibilities. It can either be 0 or positive or negative. And this right here is going to help us determine which one of these it's going to be. So let's talk a little bit about what imaginary numbers actually are and why we would get them if the discriminant is equal to 0. So imaginary numbers are written like this, with an I, a little fancy I guess you could say. And this stands for imaginary. And the way we read this would be something like, okay, 2I. And this would mean that 2 is still the number 2, but in an imaginary sense. Now, let's get a little bit more into detail with what I mean by imaginary, okay? Now, we all know that whenever we have, let's say, for example, the square root of 4, we have the answer of 2. Whenever we take the square root of 4, we get an answer of 2. And this is because 2 times 2 is equal to 4. But there is another answer. And the other answer is also negative 2. Because negative 2 times negative 2 will also equal a positive 4. This is because a negative times a negative will always give you a positive. So then, where it gets a little bit tricky is, what then is the square root of negative 4? In other words, what two numbers can I multiply together that are both the same that will give me negative 4? And you run into a problem because if they're both the same, if they're both positive, or if they're both negative, then you will never be able to get a negative as your answer. And so this is where imaginary numbers come in. And imaginary numbers say, you know what, I'm going to go ahead and make it so that when you go ahead and multiply these two numbers together, you will be able to get a negative. And the way they did that is pretty neat. They said, hey, what we're going to do is we're going to make I be equal to the square root of negative 1. So what does this mean? This means that whenever I take I and I square it, then my answer is negative 1. So you see, now that we've done that, we can actually say, okay, well then my answer to this is going to be 2I. Now why is that? Okay, well let's see what happens. If I go ahead and multiply 2I times 2I, well, 2 times 2 will equal to 4, and then I times I is I squared. And I squared is the same thing as negative 1. So what I have is 4 times negative 1, which would equal negative 4. So this is the reason that we use imaginary numbers, because now we can take the square root of negative numbers and have it not be a problem. Now, there is one slight problem with imaginary numbers, and it's kind of like what you would imagine. Because they are imaginary, they are not seen on the graph. At least a regular graph. So for that reason, even though this has two solutions that are imaginary, you will not see them as x-intercepts on the graph. Okay? So let's actually try a problem out, okay? And for a problem like this, I'm gonna go straight to your gizmos. Now that everybody understands sort of what we're doing with this, let's actually work out a problem, okay? Now we can check out another one of these, how to find how many solutions, check. What imaginary numbers are, check. And now the last thing we're gonna go over is, okay, actually using and applying the quadratic formula. So let's see here. Okay, so here we have the gizmos that I assigned you guys to work on. And we have an equation in standard form with A, B, and C. And here we can even click this to show us the discriminant computation, which says the discriminant again is b squared minus 4ac, and they tell us that it's equal to a positive 16. Okay, so if it's a positive 16, then look at that. When a discriminant is positive, it's a positive number, there's two real solutions. So let's go back and check if that's true. So yeah, it looks like there are two real solutions, one here and one here. We can also show the axis of symmetry, which again is the line that crosses right through the middle of the parabola. And here we also have the formula for the axis of symmetry. Now, let's play around with this a little. We can keep this positive. We can make this negative. And notice how my graph is changing. And C is going to help us to move this in the imaginary direction. You see how now that C has gotten pretty big, we actually had to move the graph up, which means that now my solution is going to be imaginary. So let's move this back down to, let's say, -3. And we'll move a to a positive 2. Okay, so we have 2x squared plus 2x minus 3. So we went ahead and copied the problem over. 2x squared plus 2x minus 3. And we're also going to write down my quadratic formula. Now this is something that I need you guys to have memorized, because it's going to be very, very important for you guys to know this in your later classes, and it's going to make your life a whole lot easier. So it's going to be very important for you guys to know your quadratic formula, right? This one right here. So let's go ahead and write it down one more time. We have negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. We're going to go ahead and highlight this part right here, because this is my what? This is my discriminant, right? Maybe we can highlight it in pink color. Okay. So remember, that's my discriminant. Now, what we're going to do is we're going to have to go ahead and find out, okay, what is my A? What is my B? What is my C? And we get that from, once again, ax squared plus bx plus c. This is, again, the standard form of a quadratic equation. So I look to this and I say, okay, my A is 2. Okay, my B is also 2. And my C, don't jump the gun and think that your C is 3. Your C would actually be -3, because this formula says that it should be plus C. And this says plus a -3. Okay, so the first thing we're going to do is we're going to go ahead and plug these values into my discriminant. So I'm going to have b squared, which is going to be 2 squared, right, since my b is 2, minus 4 times a, which is 2, times c, which is -3. Now, what I want you guys to do is I want you guys to always follow your order of operations, all right? So the first thing that we need to do is remember PEMDAS. So PEMDA stands for parentheses, exponent, multiplication, division, adding, subtracting. So the first thing that we need to do here is parentheses. There are none. So we got that checked off. Now, E stands for exponent. So we're going to go ahead and have to do this first. 2 squared. Well, that's just going to give me 4. And then the next thing we do is multiplication. So we have multiplication and we go in order, right? Multiplication or division, we'd go in order of what we have, right? So we have 4 times 2, which is going to give me 8. And then 8 times a negative 3. So we have 4 minus, I just brought that negative down. And then 8 times negative 3 gives me a negative 24. So what I have is 4 minus a negative 24 minus a negative. We'll make this a positive. So I have 4 plus 24, which gives me 28 as my discriminant. So because this is a positive number, I will have 2 solutions. 2 real solutions, I should say. So the next thing I'm going to do is I'm going to plug in the rest of the numbers to see what my actual answer is going to be. So I'm going to have negative b, so negative 2, plus or minus. Now, what is the reason for this plus or minus? I'm going to use this equation twice. One time I'm going to add, and the second time I'm going to subtract here. So negative 2 plus or minus the square root of the discriminant, which we already found is 28, divided by 2 times a, which is 2. So let's go ahead and try to simplify this. So negative 2 plus or minus the square root of 28 divided by 4. Let's see if we can actually go ahead and simplify this a little bit more. So negative 2 over 4, we're actually going to separate this equation. So watch what I'm going to do. I'm going to say negative 2 divided by 4 plus or minus, can we simplify the square root of 28? Let's go ahead and make sure that we can't simplify that before we move on. So the question is, can we simplify this in any way? Well, 28 is 14 times 2, and 14 is 7 times 2. And look at that, since we have this 2 here, we can actually take that 2 out and leave a 7 inside. So we're going to take out that 2. Square root of 7 divided by 4. So now we're going to go ahead and simplify this. Now, if you don't really know what I did right here, I just simplified this square root by doing this, finding the factors of 28. And then because this is a fraction in which you are adding or subtracting in the numerator, you can actually separate this out as long as you have the same denominator on both sides. Okay? So not something that has changed the equation in any way. Now, we're going to go ahead and simplify this into negative 1/2 plus or minus the square root of 7 over 2. So this is actually the way that I'm going to want your answer, because this is the most exact way. This is the most precise, the most simplified way that you can actually have your answer. And if we look at the Gizmos, they actually give you 2 answers that are both in decimal form. So what I want to do is I want to actually go ahead and solve this just to see if they give you the right answer. Okay? So we have negative 1/2 plus or minus the square root of 7 over 2. So what I'm going to do is I'm going to go to my favorite online calculator, which is actually called wolframalpha.com. And I'm going to put in the value that I just got, negative 1/2, and I'm going to do it one at a time. So first is plus, and now I'm going to say the square root of 7 divided by 2. Now we press enter and see if it looks like what we're looking for. Okay, so negative 1/2 plus the square root of 7 over 2, and the decimal approximation is 0.8228. So it's actually very close to what we got over here. And if we put in the second form of this equation, minus, we're going to get negative 1.282. So negative 1.82. So there we go. We were able to find the value of our equation. So guys, I hope that this helped. I hope that now you understand a little bit about how to find the solutions of the quadratic formula. We introduced the quadratic formula. We found what are solutions. We found how to find how many solutions. We explained a little bit about what imaginary numbers are. And we also did an example with the quadratic formula. Now, to end this video, I'm going to go ahead and do one more example, but this time one where we get an imaginary solution. So if you notice here, the solution to this equation should be imaginary. So let me show you what that looks like. Okay, so if I have the equation x squared plus 2x plus 5, x squared plus 2x plus 5, then what we are going to do is we are going to write down my quadratic formula, negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And we're going to plug in these numbers. Remember, my a, my b, and my c. In this case, a is equal to 1 because we don't have a number there. So remember, whenever we don't have a number there, it's just a 1. Our b is a positive 2, and our c is a positive 5. So once we go ahead and plug these in, if we plug them into our discriminant, we're going to figure out whether we have real solutions, one solution that's repeated, or imaginary solutions. So let's go ahead and plug them in. We have 2 squared minus 4 times 1 times 5. 2 squared is just 4, minus 4 times 1 is 4, times 5 is 20. So 4 minus 20 gives us a negative 16. So we're going to have negative 16 as our answer, which means we're going to have 2 imaginary solutions. Now, here's a little note, little asterisk. Imaginary solutions always come in pairs. So will you ever be able to have just one imaginary solution, or 3 or 5? No, you will never be able to have an imaginary solution that comes in an odd number of solutions. Okay, so if there are only one imaginary solutions, or there's 3 imaginary solutions, then you're missing one. They always have to come in pairs. Okay, so that's just a little side note for you guys right there. So we know that we're looking for 2 imaginary solutions, and what we're going to do is we're going to plug everything into the quadratic formula. Okay, so negative b, which is negative 2, plus or minus the square root of negative 16 divided by 2 times a, which is 2 times 1. So once again, negative 2 plus or minus the square root of negative 16. Well, the square root of 16 is 4, and since we have a negative, we're just going to add an I. So this is actually going to be plus or minus 4i, all divided by 2. Now I'm going to separate this like I did my other problem. So I can go ahead and get negative 2 divided by 2 plus or minus 4i divided by 2. So negative 2 divided by 2 gives us a negative 1 plus or minus 4i divided by 2 gives us 2i, and we have our two solutions, -1 plus 2i and -1 minus 2i. So these are going to be our two solutions right here. Now let's check Gizmos to see if those are our answers. We have -1 minus 2i or -1 plus 2i. So it seems that these would both be our correct answers.